Welcome to Brain Vision.
Quick note that I'm saying that P stands for period because I didn't want to have two T's for temperature and period. But okay, delta T is going to be, well, we end with 30 degrees Celsius. We start with 20. So I'm just going to say right off the bat, that's 10 degrees Celsius. Now, the equation for the period of a pendulum, say P, is equal to 2 pi square root of L over G. Now, let's take an infinitesimally small portion or change in that period, delta P, with respect to L. So dP is going to be equal to 2 pi, or I should say dP over dL, is equal to 2 pi times 1 over G times 1 half 1 over the square root of L. We can rearrange this and write dP is equal to 2 pi times the square root of L over G times 1 half times dL over L. Now notice that this is equal to this. So we can say that our change in momentum is going to be equal to period. Our change in period is going to be equal to the initial period, P naught, times 1 half times dL over L. Now we can kind of change symbols once again. Instead of dP, we can say, well, delta P, right, is equal to P naught 1 half delta L over L. Now you don't necessarily have to make this change, but it's helpful when we know the linear expansion equation. Delta L is equal to alpha L naught delta T. But anyway, we can plug that back in. So delta P is going to be equal to P naught over 2 times alpha L naught delta T over L naught. The L's will go away, and we will get our change in period is going to be the initial period over 2 times alpha delta T. Now let's plug in our numbers. So our initial period was just 1 second. So it's going to be 1 half. Alpha for brass is 19 times 10 to the negative 6. And then our change of temperature is 10 degrees Celsius. So therefore our change in period is going to be 9.5 times 10 to the negative 5 seconds. Now that was just the first part. Next part, not sure if I labeled part A above, but anyway, part B, how much time is lost in a week? Well, how many seconds are in a week? So we know there are 7 days in a week. Each day has 24 hours. Each hour has 60 minutes, and each minute has 60 seconds. So that's our total seconds in a week. I'm just going to say seconds per week. But we can take this value, 7 times 24 times 60 times 60 again, and multiply that by our change in period, which is 9.5 times 10 to the negative 5 seconds. And get that we lose 57.456 seconds. Because now each time the pendulum goes across 1, it's supposed to be 1 second. So we lose 9.5 times the negative 5 seconds per 1 second of the pendulum. So how many seconds are there in a week? Well, we found that with this expression here. So we just multiply it by seconds lost per pendulum swings, and then we get our solution.